Hi, and a good day, everyone. This is our last topic for Zoo 255, approaches to manage invasive animal species. Invasive species can be enormously costly to manage. Major challenges arise from the large number of species involved, from distinguishing those that are invasive from those that are not, and the expense of acquiring and assessing the information needed to support decision making. In this study, they emphasized on prioritization tasks. Prioritization takes place within and across stages of the invasion process, both before or the pre-border or after post-border invasion. It is therefore relevant to prevention and control objectives and may be supported by a range of analytical decision support tools as shown here. Each focus, species, pathways, and sites has a particular data requirement. In each case, the typical output used in decision making would be a ranking or ordered set of categories, or those species, pathways, or sites where action would most effectively prevent or mitigate the impact of biological invasions. So the saying goes, an ounce of prevention is worth a pound of cure. Biosecurity is the assessment and management of potentially dangerous infectious diseases, quarantine pests, invasive alien species, living modified organisms, and biological weapons. In New Zealand, not only can dogs be man's best friend or everyday work companion and dependable and dedicated guard, at many borders, airports, and ports of entry, they are now preventing the spread of agricultural invasive species, and they are called biosecurity dogs. New Zealand has developed one of the most comprehensive agricultural biosecurity systems in the world. Initial pre-border stages deal with threats at their place of origin. Thus, for the importation of goods, evidence is required from the exporter demonstrating that offshore biosecurity requirements have been fulfilled. These pre-border actions are often supplemented by pathway risk analysis in conjunction with physical interventions at the border itself, such as passenger baggage, vehicle and container inspection. This may also include detection systems such as what I have shown you before, sniffer dogs, and of course, X-rays. Predicting animal invasions is also a strategy to prevent future invasions. In this paper entitled Potential of Remote Sensing to Predict Species Invasions, a Modeling Perspective, animal species can be detected based on proxies and surrogates of animal distribution, such as habitat suitability. In this example, reconstructing land surface temperature maps from remote sensing may allow the prediction of the suitability for the spatial distribution of tiger mosquito Aedes albopictus and the forecasting of its spread in the future under different climate scenarios. This figure represents the potential spread of Aedes albopictus in South and Middle Europe in 2013. Not too many countries use science-based surveillance methods to prevent invasions, and few have the political will to enforce strict border control. Thus, upon entry and establishment of invasive species, countries are faced with problems on how to effectively manage invasive animal species. Various approaches may be through mechanical, chemical, biological, or integrated approaches to prevent further damage of the invasive animal species. Eradication is feasible upon early detection. This is why biosurveillance is important. Usually, however, there is insufficient surveillance, particularly in natural areas, to detect an infestation in its early stages. Eradication may be through applying singly or in combination chemical, mechanical, and biological methods. In this paper, they document the eradication of house crow from Socotra Island in Yemen. With a pair of birds arriving in 1995 and 1996, the population increased and a bounty system helped curb the population, but not totally eradicate the population. Thus, in 2009, professionals were hired to shoot the birds, and finally, the crows were eradicated on the island. By observing the condition in the Philippines, we can say somehow that Filipinos have learned to live with invasive alien species, right? Populations are only controlled when there is an infestation already that threatens the economy or health of the people. Various control methods include the use of poison baits, mechanical traps, or use of the bounty system and biological control. Back in 2019, residents of Batasan Hills in Quezon City were offered rice in exchange for rats. This was due to the leptospirosis outbreak in the area. This was eventually halted, showing that such control method is not sustainable, or perhaps it lacked science and planning in how it was executed. You might have seen this in the news. A well-meaning barangay captain in Old Balara, Quezon City, in August 2019, in the hope of controlling invasive mosquitoes at the time of a dengue outbreak, released about 1,000 toads. And of course, we all know that this move will do more harm than good to the ecosystem. Jones et al. In 2021 reviewed the use of exclusion barriers to limit the spread of aquatic invasive animal species. The use of these barriers have been concentrated in North America, Australasia, and Europe. Physical barriers such as weirs, exclusion screens, and velocity barriers have been most widely used, followed by electric and chemical barriers. Fish were the most targeted taxa, followed by crustaceans, mollusks, and amphibians. Most studies have been moderately successful in limiting the passage of alien invasive species, with 86% of the barriers tested deterring more than 70% of individuals. However, only 25% of studies evaluated barrier impacts on native species. This review highlights the potential of using exclusion barriers to become an effective tool in certain situations. This figure from Lennox et al. 2015 shows a conceptual framework integrating physiological disciplines within invasive species management objectives, predicting invasions, preventing invasions, and controlling invasions. Hierarchical boxes connected by dashed arrows represent barriers along the invasion process as introduced species established as invasive. Intervention against invasions can be implemented with the help of physiological knowledge. Shaded lines show where intervention can be aimed with various physiological tools. Methods with each physiological discipline may be applied in order to mount a barrier are also shown. This shows the strategy against invasive alien species. The optimal strategy evolves over time following introduction. The longer the time since introduction, the more the efficiency of management decreases and management costs increase. There are a lot of information on invasive alien species management, and it seems that approaches are a case-to-case basis. So for your term paper, what are the approaches to manage the invasive species you have chosen? Finalize your term paper, and then each of you will prepare a PowerPoint presentation to be scheduled at a later date. Thank you for listening and have a productive week ahead. Stay safe, everyone.